All right, in this lesson, we are going to talk about parallel and perpendicular lines. And so two or more lines are called parallel if they never intersect. Okay, and then two lines are called perpendicular if they intersect at a right angle, which is 90 degrees, a 90-degree angle. Okay, so parallel lines look somewhat like this, and perpendicular lines intersect at a right angle. And so they could be horizontal and vertical, or you could have a situation where they're both slanted, something like that. Okay, and so we have two parallel lines in these next two examples, and so we're going to practice writing their equation. So I'm going to call this equation 1 and this one equation 2. Equation 1, equation 2. And so for equation 1, his y-intercept is 1, and his slope, rise is 1, run is 2. And so his equation, y equals mx plus b, would be 1/2 x plus 1. For equation 2, his y-intercept is -3. His rise is 1, his run is 2, so he also has a slope of 1/2. So his equation, mx plus b, would be 1/2 x minus 3. Okay, over here, equation 1 has a y-intercept of 2, and to find the slope, he is rising 2, running 3. So our slope is 2/3. And so y equals mx plus b would be 2/3 x plus 2. Okay, for equation 2, y-intercept is -1. And then to find the rise, it's rising 2, running 3. And so his slope is also 2/3. So y equals 2/3 x minus 1. Okay, and so what relationship, if any, do you notice between equations of parallel lines? And hopefully you notice that they have the same slope. They rise together, they run together. They rise together and run together. So same slope. That's why they are never intersecting, same slope. Something else that's important to notice is that they have different y-intercepts. If they also have the same y-intercept, we're talking about the same line. And so the key is noticing they have the same slope, but also just noticing that they're not the same line. They're different lines. Okay, so if it says write an equation for a line that is parallel to a line given by this equation. And so I can see his slope is -7. And so if I need a parallel line, I just need to make sure the slope is -7. And so my y-intercept could be 100 if I wanted it to. It could even be 0 if I wanted it to. And so anything that has a slope of -7 will work as long as he has a y-intercept other than 2. And so given a line, the maximum number of lines parallel to it is there's infinitely many. And the reason why is because the y-intercept can be anything. Okay, next we're going to look at perpendicular lines. So I will call this one equation 1 and this line equation 2. Equation 1, equation 2. Okay, so for equation 1, his y-intercept is 3, And then it looks like this is a good point. These are good points. And so it looks like we are rising 1, running 2. And so the slope is 1 over 2. So equation 1 has y equals 1/2 x plus 3. Equation 2, his y-intercept is 5. And then to pick some other good points, it looks like we're going down to right 1, down to right 1. So his slope is -2 over 1, and we just write the -2. Okay, and so y equals -2x, and then his y-intercept was 5. Over here for the next example, equation 1 has a y-intercept of 1. And then it looks like rising 2, running 3, rising 2, running 3. And so his slope is 2 over 3. So y equals 2/3 x plus the y-intercept of 1. For equation 2, our y-intercept is -4. And some other good points. It looks like we're going down 3, right 2, down 3, right 2. So his slope is -3 over 2. So y equals -3 over 2. And then his y-intercept was -4. Okay, so it says, what relationship, if any, do you notice between the equations of perpendicular lines? So once again, focusing on the slope, one thing you may notice is they have opposite signs. And then another thing you may notice is they are reciprocals. And so some people call these negative reciprocals or opposite reciprocals, but two things have to happen. They have to have opposite signs and they have to be reciprocals. And so notice 1/2 became -2, and then 2/3 became -3/2. And so just looking at the slopes, that's how you find the perpendicular slope. You have to flip the fraction, switch the sign. Okay, and so write an equation for a line that is perpendicular to this line. And so his current slope is -7. And so the perpendicular slope would be +1 over 7. A whole number is always written over 1, so his reciprocal will always have a 1 on top. Okay, and so now it's positive, and so any line with a slope of 1/7 will work. We could do the 100 y-intercept, we could do the 0 y-intercept, and so once again, there are infinitely many perpendicular lines because the y-intercept can be anything. We don't care about the y-intercept. All right, so next we're going to talk about vertical and horizontal lines, which are pretty easy. And so looking at graph A, I will call this equation 1, equation 2. Both of these are vertical lines, and so remember, vertical lines have x equals equations. X equals equations because they cross the x-axis. And so equation 1 is crossing the x-axis at -2, so x equals -2 is that equation. X equals 3 is equation 2. Okay, and then for graph B, I'll call this equation 1 and this one equation 2. Equation 1 is crossing the y-axis, so it is a y equals equation, and it's crossing at 1. And then equation 2 is another vertical line crossing at x equals 3. Okay, and so the slopes of the lines in graph A are undefined. Undefined. Anytime you have a vertical line, it has an undefined slope. Okay, and so something that an acronym for vertical lines is VUX, vertical undefined, and it's an x equals equation, VUX. Okay, and then the opposite would be HOI. So HOI VUX, horizontal, zero slope, and it's a y equals equation. So HOI VUX. If that acronym helps you, I've heard my Algebra 2 kids say that, and so I think it kind of sticks with students. HOI VUX. Okay, and so in graph B, equation 1 had a slope of 0. Equation 2 had an undefined slope. What rule could we make about lines that are parallel to vertical lines? Okay, and so parallel to vertical lines are also vertical. Also, x equals a number. Okay, so if you have a vertical line, a parallel line will also be vertical. It will also have an x equals equation. Okay, and so for horizontal lines, it will also be horizontal. Also a y equals equation, an undefined slope for vertical, and zero slope for horizontal. Okay, and so horizontal lines and vertical lines have a very obvious relationship. They're perpendicular. Okay, so anytime you have a vertical line, the horizontal line will be perpendicular to it. A line has a slope of 0, meaning it is horizontal, and it's y equals. What would the slope of a perpendicular line be? It would be undefined. It would be vertical. If we have an undefined slope, what would the slope of a perpendicular line be? It would be 0. It would be flat, 0. Okay, so for this last page, we are just going to identify whether the given lines are parallel, perpendicular, or neither. Okay, and so looking at number 1, for each of these, we just have to look at the slopes. One slope is -3, the other is 5, so these are not parallel or perpendicular. Okay, here we have a slope of -5 and +5, and a lot of people want to say that's perpendicular, but it's not. They have to be negative reciprocals. We don't have the reciprocal happening here. And so once again, neither. Okay, here we have a slope of 1/7 and then a slope of 1/7, so these are parallel. Same slope. Okay, there are symbols for parallel and perpendicular that we'll start using. Parallel is just like an 11. Perpendicular is kind of like an upside down T. So parallel and perpendicular. So if you want to start using those symbols, here we have 4/3 and 3/4. They're reciprocals, but not negative reciprocals. They have to have opposite signs. Okay. Here we have 8/6 and -9/12. These are not simplified fractions, and so let's simplify these. And so 8/6, they're both divisible by 2, so that's the same as 4/3. -9/12, those are both divisible by 3, so that's -3/4. And so now that we've simplified these slopes, we can see that they're opposite reciprocals. Opposite reciprocal. The fraction is flipped and the signs are opposite, so we know this is perpendicular. So let's use the symbol, perpendicular. Okay, y equals 10, we recognize that as a horizontal line crossing the y-axis. And then the x-axis is also a horizontal line. It's the horizontal axis. And so both of these are horizontal, so these are parallel. Keeping in mind that a y equals equation, HOI, a y equals equation is horizontal. The x-axis is the y equals 0 line. Okay, looking at number 7, we have 2/3 and 2/3. These are the same, so these are parallel. We have -3 and +3. These are opposite signs, but they're not reciprocals, so neither. Don't let them trick you with that. They also have the same y-intercept, which we don't care about. They are just intersecting at that y-intercept. Here we have 5 and 5, so same slope, so these are parallel. Here we have -7 and 1/7, so opposite reciprocals, that's perpendicular. Here we have 4/3, -3/4. So perpendicular, opposite reciprocals. Here we have 15/35 and then a -8/3. We need to simplify that 15/35. Those are both divisible by 5. 15 divided by 5 is 3. 35 divided by 5 is 7. Okay, so we have 3/7, and then we have -8/3, which can't be simplified. So these are close to being negative reciprocals, but not quite. Okay, y equals 1. Let's picture what that would look like. That is our horizontal line, HOI. And then the y-axis we know is our vertical axis. And so a vertical and a horizontal line are going to be perpendicular. Okay, here we have 2/3 and -2/3. They're not reciprocals, so these are not parallel or perpendicular. They either have to be exactly the same or they have to be negative reciprocals, opposite reciprocals. Here, x equals 5 is a vertical line. Y equals 5 is a horizontal line, and so these are perpendicular. In fact, anytime you have an x equals equation with a y equals equation, you know they're perpendicular. So down here, x equals 10 is vertical, y equals pi. Pi is the number 3.14, and it's got a lot of other decimals, but all you care about is y equals and knowing that it's horizontal. And so these are also perpendicular. Y equals 5 and y equals -5. Those are both horizontal lines, and so these would be parallel. And then x equals 5 is vertical, x equals -5 is also vertical, and so parallel once again.